Hello, everyone. I wanted to thank you for attending today's PSD Expert Insights webinar. Our presentation today will be Electrifying My Home, Technical Aspects and Real-World Results. And we are recording the presentation. My name is Chris Pachuta, and I am the Senior Business Development Analyst here at PSD. And our presenter today is Rich Androulis, our Vice President of Product Design and IT. I wanted to let everyone know if you have any questions during the presentation to please post them in the questions box and we will address them at the end. And without further ado, I will pass this over to Rich.
Thanks, Chris. As Chris said, my name is Rich Androulis, and I wanted to talk today about the electrification journey that I've been on with my home with my family. This is overlapped with some significant research we've been conducting at PSD around cold climate heat pumps, and the juxtaposition of the two has led to a number of interesting insights that I think are worth sharing. Just a quick disclaimer, I've been at PSD for 15 years and I've picked up a fair amount of building science, but I do not claim to be an expert. I will try to answer as many of your questions as I can, but many of my answers will be through the lens of my home rather than industry-wide. This presentation will be more technical than the LinkedIn article and showcase some of the tools that we've been building here at PSD and show how they can work in a real-world situation. All right, next slide. So a brief agenda. We'll start with some background, talk about what was done to the house, and then what did I do, what our energy and cost impacts were, and then comparing those results to a model. And finally, we'll wrap with what was learned and what we might have done differently. So yeah, next slide. So just brief background. Our home, it's a 100-year-old single-family detached home in downtown Ithaca, New York. And Ithaca is upstate New York, so it's a cold climate. It had an existing boiler with baseboard radiators. The boiler was only about 15 years old, but it was starting to show some signs of age. And the hot water system was a sidearm tank off of that boiler, so it would need to be replaced as well to replace the boiler. The home had pretty extensive weatherization work, including above grade wall insulation, done in 2005 before we even bought the house. That work was actually done by Performance Systems Contracting, subsidiary of PSD. I joined PSD specifically because I believed in the mission to combat climate change through building efficiency. And my wife was actually a large part of the driver for getting this work done. Our goals were twofold. One was reducing our carbon footprint. The other was improving the indoor air quality, as my wife and all our children have asthma. Costs, like utility costs, was really not a concern. I knew enough that I wasn't expecting to save a ton of money. We were on a gas boiler, and moving to electric, it was definitely not going to be, best will be cost neutral. Next slide. So from a timeline view, just high level here. So we had another audit done. We had, once we bought the house, it was about 10 years ago now, and it basically confirmed there were no serious envelope issues. That previous work was still holding up really well. The only real recommendation was to replace the dehumidifier in the basement with an industrial level high efficiency unit, and we'll come back to that later. Then we got an EV charger installed. And then we started talking about heat pumps and water heaters and induction stoves, and those finally got installed in 23. And then we finally had the rim joist and the basement wall spray foamed earlier this year. The next slide, we'll go into a little more detail here. So just to get into some of this detailed steps. So after the EV charger was installed in 21, we decided the next step was heat pumps. And we started talking, to our contractors around then and held off for a year just to get the financing right. I mean, they're not cheap. But then we came back in May of 22, signed a contract, put down for 2 mini split units So 2 outdoor units. One was serving the downstairs with 2 indoor heads, and one for the upstairs with 3 indoor heads and 1 per bedroom. We also had the heat pump water heater installed at the same time. And so we put the contract in May of 22, but none of it was installed until January 23 because supply chain and then getting on the schedule for the contractor. And so come January, we turned everything on, and it was okay, everything worked. But a year later, we realized how cold the basement was. We had removed a heat source, the boiler, and put in a heat sink, the heat pump water heater. And so we said, all right, we need to get the rim joists and the basement walls spray foamed just to help address some of that really bitterly cold in the basement. So that was done to the house. And then I'm going to talk about what I was going through at the same time. Again, with just enough building science knowledge to be dangerous. So next slide. So what did I do? I played with settings a lot. I know you're not supposed to, do setbacks with heat pumps, but it's really hard to rethink that, just letting a system run will use less energy than stopping and starting it. This concept of minimum capacity is also really hard to grok in reality. It didn't help that the remote controls for these units come with a ton of buttons. Designers of these remote controls clearly didn't know any building science, so they would have removed about half of those options, like all the time settings to do setbacks. But the main issue, of course, was the downstairs. It was a big open area with old windows and sitting atop an uninsulated basement. The bedroom units were actually pretty easy because it's cooler at night when you're sleeping. So we could just leave the thermostat at 64 and just leave it there all day long. But the downstairs, we needed it warmer. And I first set it and tried to leave it alone. But then the first month's bill came in and it was higher than I was expecting. So I started playing, and just to see what an optimum setting would be, optimum being comfortable, but not, costing us an arm and a leg. And finally settled on that setting, but also a sequence of events to say if we needed a little bit more heat when it was a colder day. So first step was actually to turn on the ceiling fan. And this was my wife's suggestion. The indoor units are mounted very close to the ceiling and hot air rises. So having not all that hot air trapped at the ceiling didn't do it all good. But putting the ceiling fans in and maybe bumping it up in terms of speed from the low to the medium when it was really cold actually made a huge difference. Because again, we had 2 units for the entire downstairs, and these rooms were quite open. So often the cold spots were not, they're not next to where the mini split heads were, they're further out. So really dispersing the heat throughout the floor was really the important step. And so if the ceiling fan wasn't able to just, disperse the heat, then we would just increase the fan speed on the units. And then only as a last resort will we actually increase the temperature. And it was just 1 or 2 degrees. And this was like on the coldest days. And, even though it's been insulated and air sealed, it's an old home and it's leaky, and the demand increases on those really cold days. That said, I want to say, we never reached a point where the heat pumps could not heat the house. I mean, we took the boiler out. There is no other backup source for heat other than some, electric space heaters. Most of this issues was just me being overly cautious, miserly about spending the money. Now that we've gone through 2 heating cycles, though, I really don't worry about it much. Now that I've got that sequence of, of steps and how to adjust, it actually works pretty well. So what was the impact of doing all this work? So next slide. So on the cost side, the initial utility bills went up a lot. The month prior to installing the heat pumps, the total bill for both electricity and natural gas was about $350. The month after was $530, and then kept going up. And it finally topped out around $700. It's this spike down here at the bottom. You can see in the middle of the chart. And then I've never had a utility bill that high. And mostly I was thinking about like resale value of the house. It's like, oh God, I've completely screwed this up. How, who's going to buy it with utility bills that high? But eventually we looked into it, and realized, oh yeah, we're using a electricity supplier that was supposedly greener, but of course at a premium. And you figured, all right, I've done enough to reduce my carbon footprint. I really don't need to pay that premium for my electricity as well. And so switching up that green supplier brought the prices down quite a bit. And so it ended up actually that the total price for 2022 with that green supplier was almost exactly the same as what we spent in 23 without the supplier. So, from a cost neutral, cost things, it ended up being pretty neutral. But again, we switched the supplier. On the energy side, things were a lot better. We started, the gas peak was around 130 therms in the winter, but then, an annual average around half of that. And we still have a clothes dryer, so we still use about 4 therms a month. And eventually we'll get rid of that clothes dryer. Right now, when we looked into it, it was like, well, the embodied carbon of the existing clothes dryer is higher than switching off of it to an electric, but we need to get out, want to cut the gas line off. So it'll happen sometime in the next few months. Electricity usage went up about 50%, probably not too bad. Of course, our baseline was higher because we had that EV charger already. So, and from a CO2 impact, even with switching from that green ESCO to just the utility, we still saved about 4,000 pounds a year, which is just over 20% of what we've been using. And funny thing, when I looked into that green supplier, it was only saving about 1% on the CO2 over the utility side. I mean, we're in upstate New York. There's some, fair percentage of hydro, in the utility situations, in the utility supply. So, but it was kind of pathetic how little that was saving. So the next step, obviously, if we want to really reduce our CO2 is to get off the utility and move to like a community solar, since our house isn't really well situated for PV panels directly. Next slide. So the other thing we did around this time was install an Emporia sub-meter device. And there's plenty of other devices like this out there, but this was pretty reasonable. It lets you monitor the main circuit and up to 8 individual circuits as well. They have a model, you can do 16 circuits if you wanted. And if you want, you can really geek out on your data here. There's a mobile app where you can track second by second usage across all those sub-channels. Or you can download a CSV with like a year's worth of data. And I'll see that in a second. When I compared it to the utility meter reads, it was within about 10% of the utility bill. I mean, these things work by monitoring the current through the wires coming out of the circuits, or into the circuit. So it's a little different than what the meters are reading. So it's, but 10% is pretty good, especially for directional understanding of how things, how the house was using energy. Couple of just points to call out is you do need to pay attention. Some of the clips do come loose. I lost most of my hot water feed for 23 because I wasn't paying attention. At least not to the hot water feeder. I was paying a lot of attention to the heat pumps, but I wasn't paying much attention to everything else. And it's also tied to your Wi-Fi network. So if you turn off your Wi-Fi, like we do when we go on vacation, it means you've lost access to your data for that time period. So, just little things. But go to the next slide. We can see, what this gets you. And so this is weekly data for about the last year. So it started, from July 1st of last year through June of this year. But then it's sorted by the actual calendar week number. So week 1 is January 1st. So the first half of this is, it's 2024 data, and the second half is the second half of 2023. But you get a sense of the overall trends here. And, you can not all the circuits are monitored, so there's some gaps between the totals and the sum of the submeters. Certainly the water heater is not well represented here, so it's that some of that gap is because of that missing data. But you can call out a couple of things. So the going from the bottom up, that teal blue is the downstairs heat pump, and that's really the significant driver. The upstairs heat pump, you can see, is using a lot less energy. Just smaller rooms, they're better insulated, they've got better windows, all that stuff. You're not sitting on top of a cold basement. So, so really, controlling usage of that downstairs is really, that's why I was focused there. The next one up, though, is interesting. That's the basement usage. And you can see that, especially the second half of 23, it was pretty high. And what's down in our basement, the water heater's on a separate circuit, so it's monitored separately. So this is things like a chest freezer, a small refrigerator down there. But the big one is the dehumidifier. And so, I was watching that. It's like, oh man, that's just a big, it's really a very sizable amount of usage. And finally, as we'll see when we get into some more analysis, realize that, the dehumidifier was really fighting with the heat pump water heater on conditioning that basement air, because the hot water heater would take energy out of that moist air as well and could use that to heat up water heater. So having the dehumidifier sort of jumping the gun and trying to do that first was making both of them work harder. So earlier this year, I reset the relative humidity percentage on the dehumidifier to just be a lot higher. So it only kicked in if things got really humid down there. And you can see in the first half of this year, especially starting around week 11, that basement usage just went almost to nothing. So yeah, dehumidifiers, who knew? Then of course the EV charger is a big use. I mean, my wife drives 400 miles a week with an EV. It's charging every night. It's, it uses a lot, but in terms of the cost accounting and the budget, that really belongs in the transportation budget. It's not really a house budget, even though it's now showing up on the house bill. So it's something to keep in mind as you're looking at, utility bills and other things, is that how you account for that and just mentally keep track of things. There's a little trickery or little just awareness of things you need there. All right, next slide. So, as I mentioned in the LinkedIn article, that was all good. And I can say, yeah, okay, but cost was, it stayed where it would, with all the adjustments we made with the suppliers. But overall, the energy usage went down. CO2 is definitely down. Air quality is definitely greatly improved. So, but this was left me wondering, was this all working as well as it could? And did we actually put in the best heat pumps we could have? What other things could we have done if we had known more information at the beginning? So, as I said, as I'm going through this journey for my house, PSD was building tools for modeling the energy savings coming from both load reduction and installing cold climate heat pumps. So we didn't have access to this information when we were making those decisions because the tools haven't been built yet. But I said, all right, well, now we've got them. Well, let's at least see what's going on. So I put my house, our house into this tool and started comparing. And so then you get a report that looks something like this. So in this case, I'm using actual utility data, not the Emporia data, and regressing it to generate a weather normalized baseline usage. We can then compare the predicted usage from the model and the actual usage in that, like 2023, that post retrofit period, relative to that historic weather normalized baseline. And we can calculate savings there. So in that top chart on the left, the blue bars are comparing how much energy we're now using relative to what we would have expected to use based on historical baseline. And so positive numbers is positive savings. So it means on a net KBTU basis, we're saving relative to my baseline. I mean, yes, we're using more electricity, but we're using a lot less gas. So on the whole, though, it's, the heat pumps are more efficient as expected. And then the yellow line is then showing the expected model savings. Again, comparing the modeled usage relative to that same historic baseline. And I looked at this and was like, all right, what's going on with those cat's ears on those 2 points? And so I dug in a little bit more and realized that that historic baseline, that, the regression on it's kind of, rough. It was just had 12 monthly data points. So there's just some spike in usage in those months that is not in the model. The model is nice and smooth. So anyway, it just shows up that way in the savings. But if you look down at the bottom, this is sort of showing the cumulative savings month over month. And one of the most, and so it's clearly that we're not saving as much as we could have, again, we'll put could in quotes. But one of the things that's very interesting is that slope between those 2 lines, the slopes are more or less constant. And which means that it's most likely the discrepancies are in the base load. Because if it was in heating, I would expect to see much steeper slopes in the heating seasons or the cooling season. But given, there's a slight tweaks. You can see where those cat's ears kick in. But for the most part, it's pretty flat. And we already know the home's using a high base load, again, that dehumidifier. And so it's, so anyway, so that's all there. And of course, you have to account for the fact that the actual usage has the EV charge, but the model doesn't. So, making sure you're subtracting that out and taking care of that. And then the wall of numbers here on this right, I'll just call it the bottommost number, which is that realization rate. And I'm saving about 60% of what the model would expect. So again, it's going with the model. So we're testing the model. This is the tools that we build is taking simplified user inputs and building out, complex models from it. So there could very well be issues, some assumptions we make in translating those simplified issues. That's one of the reasons I wanted to get my home in here. But it's still valuable to dive in and see what could be causing those discrepancies. Like I said, no baseload usage is high. We are also, we are working on adding some additional inputs to the model to allow a user to tweak the baseload. So we'll see if that's the source or not. But even if we end up adjusting the model to better align with the reality, it's still highly valuable to point out where those real-world complexities can have a significant impact on predictions. For instance, that heat pump water heater fighting with the dehumidifier, or on cold days, the heat pump water heater pulling heat, not just from the basement, but probably from the first floor as well, and then pulling heat that was generated by the ground floor heat pump. Then 2 of them start fighting each other out. So, these are real issues we need to figure out. I mean, I started, once I realized what was going on and looking at this analysis, it's like, all right, well, let's try setting the water heater to just resistance mode on the really cold days. By itself, looking at just the hot water system, that probably doesn't make much sense. But thinking about it with interactions with the other systems, it probably could be using less energy. We need more data. I only did that starting in late March, so we need another heating season to go through to see if that really did make a difference or not. But it's insights like that we can start drilling into with having that point of comparison. All right, next slide. So the other part of our tool is in calculating design loads for these cold climate heat pumps. So this is a sample report from our tool that can drill into equipment sizing. So the upper chart is based on existing equipment, the equipment installed in our home. And the 2 yellow columns are really what we want to highlight here. And the leftmost is coming from the model and saying, this is what I expect the load to be. And then the contractor can apportion it to say how much of that load is in the upstairs zone or the downstairs zone. And then compare it to the actual equipment installed to support those zones. These are mini splits, so it's not really zones, but anyway, those areas of the house. And you can see the downstairs was pretty close. I mean, actually, the piece of equipment, it's not really oversized that much over the model. It's oversized compared to what the contractor calculated, because they were much lower. They were about 40,000 total, but not terribly so. So, and given equipment size, you're never going to hit it spot on. So having it slightly oversized is okay. The upstairs, again, we have a constraint that we had 3 separate bedrooms, and so if we wanted to put a head in each of them, there's only so small you can go. So even though really you wanted it to be smaller, there are some constraints and those, and just how the building geometry is laid out. And then the bottom chart is just showing, like, if those who have seen a manual J, you'll see similar charts like this, where you have each of the component parts of the house contribute, their contributions to the overall load of the house. And we can do this now with our tool, is using that information, that as we make envelope improvements, we can see what the impact is to each of those components and their contributions. So with one run, if you will, we can then calculate not just the expected load of the base building, but here's what the load should be if you make these envelope changes going forward. Now, there's not much change here because the home was already insulated and it was pretty tight. So, it's not showing a very large delta here. But it also says, that when we insulated the walls and floors, it's not making that much of a difference. When we insulated, the basement walls and rim joists, it's not making that much of a difference here. So, the fact that we did the spray foam after the fact, after we installed the heat pumps, it probably didn't have that huge an impact on the sizing of the equipment. So, all right. Okay, so let's go to the next slide. So, all right, so let me just explain this chart before I get into why this is so important. So what this chart is showing is the total energy use of heat pumps. And there's 2 heat pumps. One that was the blue line is the one we actually installed, and then the second is the second set of heat pumps. I'll explain in a second. And the y-axis is just showing the total kWh that heat pump is using within that temperature range. And this is total. So what this was calculated by figuring out what the average value was per that temperature, and then multiplying by the number of hours the home actually spent in 2023 at those temperatures. And so we can scale it up and see what where the significant impacts are. And there's a couple things to point out. One is that the home doesn't actually spend a lot of time below 30 degrees, even though we're in a cold climate. So this led us to thinking, all right, we built our tool on top of the NEAP database of cold climate heat pumps. Those who are familiar with the NEAP database know that they're collecting this huge list, like 100,000 or more now, of air source heat pumps, including manufacturer specified performance characteristics at various temperatures. Not, for our concerns, the cold climate, meaning 47, 17, and 5 degrees. And so we built our tool to take those characteristics and improve how models would calculate heat pump usage with for those cold climate heat pumps. And this then allows us to compare 2 heat pumps that have similar HSPF or similar capacities, but different temperature specific parameters. So here, like I said, the blue line is the actual heat pumps that are installed. You can go look them up in the NEAP database, get their full set of characteristics, and then we can go look in the NEAP database for other heat pumps that are the same size, same max capacity at 5 degrees, but have better performance at the mild temperatures. And then we could see, all right, made a difference. Not much, mostly in that mild temperature. You can see that 47 degrees. It's where that's where the gap is showing, predominantly. And it's, more or less spot on at the cold temperatures, and mostly because there just isn't that much time spent at those temperatures. So there's just isn't time to create much of a difference. So if you add up, area under the curve, you can get the total energy usage for the year. And between the two curves, it's about a 6% difference. Not, not huge, interesting. The really interesting thing, though, is that if you do a quick check on, websites for getting the price of those two specific models, the better heat pump is cheaper. It's like $600 less. So, having a cheaper heat pump would actually be more energy efficient. And this is probably the aha moment of why I wanted to have this conversation here. And you're like, oh, there's some really valuable things to say about that better heat pumps don't necessarily correlate to higher costs. It's really about what is the best heat pump for that location and for, the cold climate characteristics. And judging, do I really need something that's optimal at 5 degrees? Probably not, unless you're up in northern Alaska or, Minnesota. You're probably not spending a lot of time there. You really need to be thinking at most 17 and more likely 47, even in areas that you think are really cold climate. And just because that's really where the homes are spending time. So, final slide. So just some of the lessons learned and just wrapping up some of this. So somebody, when they registered for the webinar, did have a question about picking contractors. And so the contractor we used was recommended from a friend, but since then I've had a bunch of other people I've talked to about heat pumps who have also used the same one, had very similar experience, very positive experience. He was very into building science. But I think the main thing is, if you take away from this presentation, is you want to know how they're picking heat pumps and be clear that you want to know more than HSPF and capacity. Certainly oversizing is going to cause, utility bills to go up, but making sure you're getting those cold climate parameters correct for your location is really critical. The other thing is this concept of minimum capacity it's counterintuitive. Educating homeowners to just let the systems run, it's hard. And I think recognizing that you can educate them up front, but it really would be good if somebody was reaching back out after a month or so and say, okay, how's it going? What's going on, and making sure they, that once they've had time with the systems to use them and can see the impact, how are they really using them optimally? I mean, like I said, I know enough to be dangerous, and I still was running into this. And so, this idea that, when it's, the shoulder seasons, we need a little bit of heat, that we actually want to turn the thermostat up so we make sure we hit that minimum capacity, and it would actually spend less energy to do that. It's just really hard to grasp. So anyway, don't discount impact of improving indoor air quality. So if you're on gas, you're not going to be saving a ton of money. I mean, that's just the economics of it. But there's a whole bunch of other reasons to get off of, boilers and furnaces and things, and especially, getting the gas, equipment out of the house. Ceiling fans, almost to the point where, I mean, I would love to get some real hard data on this to just show the impact it has. But in terms of comfort, it made a huge difference, almost to the point where I would like, if you don't have ceiling fans for getting, mini splits installed, you should get them installed at the same time, just to help, especially if you're distributing, if that one head is trying to heat up a large space. And then what's the deal with dehumidifiers? Man, they're just, you would not think that they're that big a deal, but man, they suck up a lot of energy. And I would think getting a much more energy efficient version that isn't $2,000 would be really a good thing to do. So as mentioned in the webinar, I wanted to go back and take a look at this chart because I mentioned that the discrepancy between the actual savings and predicted savings from the model seemed a little high. And it turns out that even though I had mentioned in the webinar that the model does not have a car charger in the model and that you have to account for it, when I back and did the analysis again and looked in detail, I realized I hadn't actually accounted for that car charger. Once I put the car charger correction into it, you can see that the lines are more or less on top of each other, showing the accuracy of the prediction relative to the actual savings that was seen in my house. I think now we've got time for some questions.
Thanks so much for that presentation, Rich. We did have a couple of questions that were submitted with people's registration. So the first one is interested in any learnings around how important reducing envelope was or wasn't to sizing of your heat pump, if you have that.
So you cut out reducing.
Reducing envelope. So interested in any learnings around how important reducing envelope was or wasn't to sizing of your heat pump.
Right. So I mentioned this, during the presentation, but yeah, I went in thinking the house was pretty well insulated and air sealed. I mean, like I said, we knew work had been done. We had an audit, and when they had the audit for before we did the spray foam in the basement and walls, they did a full audit as well, and they were like, yeah, there really wasn't much. They really wanted me to replace my basement door with an insulated door. Anyway, there's some story behind that I'm not going to share now, but that was it. They were pushing. They also said, hey, you should get a better dehumidifier in the basement. But they didn't say anything about, hey, you should probably, as at that point, we'd had the heat pump water heater running for a year. And they didn't say anything about, oh, are you adjusting the setting, or are you, making sure the dehumidifier is not fighting with the heat pump water heater? So those kinds of things. But in terms of envelope work, yeah, I think we probably got as good as we were going to get in terms of sizing. But you're right. I mean, if you oversize, that's money you spend, A, on bigger equipment, and B, that the bills are just going to be higher.
And the other question that was posed was, what was the most surprising effect of the home energy upgrades?
Most surprising, probably that basement. I mean, just how it got really cold down there. I mean, really cold. I mean, you go down there, it's like you're dropping 20 degrees from the upstairs to the downstairs. And it was like, so, I mean, like I said, I'm really going to be curious as we go into this heating season, how much impact that has on the bills, because, the water heater not fighting with the ground floor not getting this huge sink of cold air that it's having to deal with. But yeah, dealing with basements, it's tricky.
All right. So that was all of the questions that were posed with the registrations. And we don't have any that have been posted in the question section. So I guess we could unmute the attendees and just give people a chance to answer questions if they have any.
I think people could raise hands, maybe. Is that an option here, I think? You don't want to unmute everybody, or we can. Anyway.
It looks like there is an option for raising hands.
People want to raise their hands or just type it into the question section. I mean, that was a lot of information thrown pretty quickly, so I get it. It may not be time to even figure out what the question should be.
Okay, just got one posted. Um,
Yep.
I just installed a heat pump water heater in my basement and it's cold now. What do I do about that?
All right, Noel. Um, yeah, I mean, like I said, if it's really on those cold days, I mean, if it's cold now in the summer, I don't know what to do all year, but I mean, like I said, I'm experimenting with just putting in resistance mode on the super cold days and just seeing what happens. But if it's just the water heater on its own, I mean, I wouldn't touch it. But again, that's where I'm sort of, my building science knowledge is sort of ending, and I don't. But what I would do is get an Emporia, get it attached to that circuit, and play around and see what the impacts are. Both from a temperature perspective and how much energy that water heater is using. I want the really true data geek way to do it. Get some data.
Any other questions? Oh, okay. So, what would the cost savings have been if it were not
Yeah.
switching energy?
Yeah, we probably would not have saved. It would have definitely been increased in the cost, because it's just electricity is just so much more expensive than gas on a per kBTU basis. So even though we're saving lots of kBTUs, it would have gone up. I'd be curious. Yeah, I can go. I mean, like I said, the first 4 months we were using still on that supplier. It was only, I think, May that we switched. So, um, so yeah, I have to think through how I would calculate that out. But it would not have saved money, but it probably would not have been as, costly, because like I said, the summer and the shoulder seasons were a lot cheaper. We were definitely saving more in, energy, because, the air conditioners were more efficient. But yeah, I mean, as it was, the cost was neutral. So if we kept it more expensive, it definitely would not have been a savings.
Any other questions?
Mm-hmm.
Okay. Oh,
Yep.
oh,
Got one more.
for
Yes, Matthew. Oh, it's the same. Thank you. All right. Yep.
awesome. Well,
All right. Well, thank you all for attending. Yep.
yep. Thank you so much for attending. We will be sending a follow-up email once we've got everything together for that. And I hope everyone has a great rest of their day.
Thank you all.